In this tutorial, we will see how to perform learning curve calculations. Each time cumulative production doubles, the total manufacturing time and cost fall by a constant and predictable amount. This amount is known as the learning rate. The chart on the slide shows 4 learning curves at learning rates 0.95, 0.90, 0.85, and 0.80. As you can see, the lower the percentage, the quicker the time needed to perform a task takes. Consider a process that takes 100 minutes for the first item and has a 90% learning rate. Doubling to 2 units results in 100 times 0.9 equals 90 minutes. Doubling 2 to 4 units results in 90 times 0.9 equals 81 minutes. Doubling 4 to 8 units results in 81 times 0.9 equals 72.9. Doubling 8 to 16 results in 72.9 times 0.9 equals 65.61. Finally, doubling 16 to 32 units results in 65.61 times 0.9 equals 59.05 minutes. These basic calculations can give us a general guideline, but do not allow us to see how long, say, the 25th unit would take. We will see how to handle this later in this video. In this next example, consider a process that takes 200 minutes for the first item and has an 80% learning rate. Find the times for units 2, 4, 8, 16, and 32. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. Doubling to unit number 2 equals 160. Doubling to unit number 4 equals 128. Doubling to unit number 8 equals 102.4. Doubling to unit number 16 equals 81.92. Finally, doubling to unit number 32 equals 65.64. The prior approach only works for units that are a power of 2. What we need is a way to find any time for any unit. The formula for that is shown on the slide. The time for unit n equals the time for unit 1 times n raised to the bth power. B equals ln r divided by ln 2. B also equals log to the base 2 of r. Finally, r is the learning rate. The first unit requires 900 hours and the company is performing on a 75% learning curve. We wish to find the times for the 10th, 20th, and 30th units. The first step is to calculate B. We will use B in the calculations for each unit and its value will not change. The first way to calculate B is as ln of 0.75 divided by ln of 2. That works out to negative 0.2877 divided by 0.6931, which equals negative 0.4150. We can also find B as the log to base 2 of 0.75, which equals negative 0.4150. You can use either approach depending on your calculators. They give the same results. My calculator, for example, has the ln function but not the log function. Now that we have B, we can calculate the time for the 10th unit as the time for the first unit, or 900 times 10 raised to the negative 0.4150 power. That works out to 346.1. The time for the 20th unit is 900 times 20 raised to the negative 0.4150 power. That works out to 259.6. Finally, the time for the 30th unit is 900 times 30 raised to the negative 0.4150 power. That works out to 219.4. We can quickly check to see that these numbers are approximately correct using the doubling approach covered earlier. The time for the first unit is 900. Doubling that to 2 yields 900 times 0.75 equals 675. Doubling 2 to 4 yields 675 times 0.75 equals 506.3. Doubling 4 to 8 yields 506.3 times 0.75 equals 379.7. 8 units is close to 10, but slightly less. Therefore, we would expect this time to be close to the 10th unit, but since there have been less learning, slightly higher. In fact, the 379.7 for the 8th unit is close to and slightly more than the 346.1 we calculated for the 10th unit. Doubling 8 to 16 yields 379.7 times 0.75 equals 284.8. Doubling 16 to 32 yields 284.8 times 0.75 equals 213.6. This value is very close to the 219.4 we calculated for the 30th unit, so that calculation checks out. In this next example, the first unit requires 500 hours and the company is performing on a 90% learning curve. We wish to find the times for the 10th, 20th, and 30th units. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. The first step is to calculate B. The first way to calculate B is as ln of 0.90 divided by ln of 2. That works out to negative 0.1054 divided by 0.6931, which equals negative 0.1520. We can also find B as the log to base 2 of 0.90, which equals negative 0.1520. Now that we have B, we can calculate the time for the 10th unit as the time for the first unit, or 500 times 10 raised to the negative 0.1520 power. That works out to 352.3. The time for the 20th unit is 500 times 20 raised to the negative 0.1520 power. That works out to 317.1. Finally, the time for the 30th unit is 500 times 30 raised to the negative 0.1520 power. That works out to 298.2. By taking the time T1 of 500 and multiplying it times 0.90 for each multiple of 2, we find that the time for the 8th unit is 364.5, close to the value of 352.3 we calculated for 10. We also find that the time for unit 32 is 295.2, close to the value of 298.2 we calculated for 30. So here's a question. If the first unit takes 1,000 hours and the learning rate is 90%, how much time will 50 units take? Not the 50th unit, but all 50 combined. We could calculate the time for each unit 1 through 50 and add them together. That calculation is not even hard on a spreadsheet. Just copy the formula down. However, there's a better approach. The cumulative average number of hours is represented by T sub C. It can be approximated using the formula T1 plus n raised to the b power, all divided by 1 plus b. This is the same value of b that was used earlier. That is either ln r divided by ln 2 or log to the base 2 of r. This is an approximation. It only works for larger values of n. In fact, the results for smaller values of n will not be valid at all. The larger the value of T1, the larger n must be for this approximation to be valid. Of course, once you have the average time, you can just get the total time by multiplying the average value times n. Let's go back to the example mentioned earlier. If the first unit takes 1,000 hours and the learning rate is 90%, how much time will 50 units take? At 50, n should be large enough for the approximation to be valid. You've already seen the b value of 90% calculated in this video, and it works out to be negative 0.1520. The cumulative average for 50 units is the time for the first unit, or 1,000, times 50 raised to the b power of negative 0.1520. All of that is divided by 1 minus 0.1520, or 0.8480. All that works out to 650.66, so the average time for all 50 units is about 651 hours. Taking 650.66 times 50 gives us 32,533, so making all 50 units takes 32,533 hours. The numbers on the slide are hard to see, but they give us a check of our approximation to see how good it is. The left column is the units going from 1 to 50. I have split the table into two parts so it fits on the slide better. The second column is the time for that unit. The first one is given as 1,000. The remainder are calculated using the formula we used earlier of T1 times n raised to the b power. While not shown on the slide, these 50 numbers sum to 32,142, which is very close to our approximation of 32,533 that we calculated a moment ago. The third column is a running average. For Unit 2, 1,000 plus 900 divided by 2 is 950. For Unit 3, 1,000 plus 900 plus 846.2, all divided by 3 equals 915.4. The remainder of these numbers are calculated the same way. This is the correct average, not an approximation. The fourth column is an approximation of the average we just calculated. As you can see, at Unit 2 it is more than 10% off. As we stated earlier, this approximation is not valid at smaller values of n. By the time we get to Unit 25, the approximation is only about 2% off. At Unit 50, it is only a little more than 1% off. In this next example, if the first unit takes 500 hours and the learning rate is 80%, how much time will 100 units take? Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. The b-value is ln of 0.80 divided by ln2, or a negative 0.3219. The cumulative average for the 100 units is T1 of 500 times 100 raised to the negative 0.3219 power, all divided by 1 minus 0.3219. That works out to an average across the 100 units of 167.43. Multiplying that times 100 gives us the time for all 100 units of 16,743 hours. If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.